Hello. Hello. Hello.
Check. I want to do something. Check. Which was 21. So,
Hello. Hello. Okay, these are the questions we want to solve. I think there are 9 questions in all. These are the third assignment. We've done the first, second. So, well, I'll go straight to start solving them. I was having challenge connecting the Zoom, so I decided to do it this way. I hope the lecture will be smooth. Okay, let's begin the first question. Statistical methods. The first question is, what information is necessary to calculate a confidence interval? Well, this is a very simple question. If you know the formula for calculating confidence interval, you can take the variables in the formula, and then that's all you need to be able to calculate this. So you need a mean. Let's write them down. For number one, you need the mean. It's also written as this. You need the standard deviation. You also need the sample size. N. That is for one. Question number two. What is meant by the 95% confidence interval of the mean? Okay, this simply means that we are 95% confident that the population parameter or parameters we're given is between a given range of mean or between, say, X and X. Right, so I'm going to write that. It means that we are 95% confident that the population parameter is between X and, say, Y, or let's just still use X. Or we, instead of X and X, we can say between a given range of mean. Okay, that's it. Let's look at the third question. A study of 35 golfers showed that their average score on a particular course was 92, right? The standard deviation of the population is 5. Let's take data first before we start. Three. So 3. We're told that a study of 35 golfers means that the population is 35. Showed that their average score, that is the mean, was 92. The standard deviation of the population is 5. So the standard deviation is 5. This is what we're given. So let me write here. Given we are to find A. What are we to find? Let's go back and check the question. A, find the best point estimate of the mean. Well, the best point estimate of the mean is simply the 92 given, because we're not given any certain range, right? So take that as 92. All right. The best point estimate. The best point estimate of the mean is 92, not 95, 92. B. Question B is find the 95% confidence interval of the mean score for all the golfers. Okay, so this is how we do this. First, we know that to find the interval of the mean score, the formula is it's a range. So that range is given as whereas the left was negative, this is positive. Standard deviation by the square root of the population. This to the left, this to the left, and that to the right. So here is negative. We subtract, but rather we add. What is our x? This is our mean, right? The given mean is, this is the given mean, the 92. You could also write, you could have written it as just this instead. So applying this formula, we have that, let's substitute. The mean is 92, so this is 92 minus the z-score. The z-score, you can just take note of that. We don't have the, I don't have the table here, but take note that the z-score for 90% confidence interval is 1.65. For 95% interval is 1.96, and for 99% confidence interval is 2.58. Referring to the question, let's refer to the question and see what interval 95%. We're asked to use 95% confidence interval. So because we're using 95% confidence interval, we're going to use this value, 95, 1.96. So it means that Z for 95% confidence interval is 1.96. So that's this we're going to use here. So minus 1.96 times, what is the standard deviation? It's 5. So 5 all over square root of the mean. So square root of 35. Close bracket. This is less than this, which in turn is less than, what is the mean here? 92. The given mean is 92. Instead of minus, we're repeating this, the left-hand side, but instead of minus, we make this plus because the range from the left-hand side to the right-hand side, it's a range. This is the left-hand side, and that's the right-hand side. So there's 92 plus 1.96 times 5 all over square root of 35. Okay, I tried this earlier, and I had this to be, the left-hand side to be 90.34. It's less than the mean, and the right-hand side is 93.66. Now let's confirm that. Let's confirm that quickly. Left-hand side is 92 minus 1.96 in bracket square root of 5 all over the square root of 35. Close the bracket. Let's see what this gives. Yeah, this is at 90.34. That's correct. To the right-hand side, all I need to do is to change the negative sign to positive. Change the negative to positive, and that is 93.66. So that's it. So we're done with we're done solving 3B. So it means find the 95 confidence interval of the mean score for all the golfers. So that is it. It means that the interval, the mean score interval is between 90.34 and 93.66. C. Find the 95% confidence interval of the mean score if the sample of 60 golfers is used instead of a sample of 35. Well, this is straightforward. We're going to repeat this calculation, but instead of using 35, we're rather using 60. So I'll open a new page. That is 3C. We're using N to be 60 instead. N is rather 60. So because N is 60, we've written the formula here already, so we didn't repeat that much. But take note, this is what we're going to use. N is 60. N is 60. This remains the same, 92. It's still 95% interval, confidence interval. So it means that Z value is 1.96. Still the same standard deviation of 5. So applying this, remember the formula? It's x minus this times standard deviation all over square root of n is less than mean. It's also repeat to the right, but make it positive. So the z value, the standard deviation all over the square root of n. Okay, let's work out the left-hand side. To the left, we have the mean to be 92. Sorry, it's negative. Minus this value is 1.96 times, what's the standard deviation? Standard deviation still remains 5, another square root is 60. Then to the right is still 92 plus 1.96 all over the square root of 60. Well, I had this to be 90. I had this to be 90.73 less than mean, and the right hand side to be 93.27. Now let's confirm it. Ninety-two minus 1.96 times 5 all over square root of 60. Close the bracket. Let's see what that is. 92.73. That's what I had for the other side. For the right-hand side, this is plus 93.27. That's it. So we've answered 3C as well. Now let's look at D. Which interval is smaller? Explain why. Okay, so let's find out which interval is smaller. What is this interval? For n is equal to 60, what is the interval? N is equal to 60. What's the interval? The interval is okay. To the left, what did we get? So this is okay. I think they're all positive. So we had here 90.73 was other is 93.27. What is the interval? The interval is 93.27 minus 90.73. What is this? .27 minus 90.73. 2.54. 2.54. Let's say the first one. The other one, what did we get for this? We had 90.34 and 93. So the difference is 93.66 minus 90.34. 3.32. 3.32. So for the first one is 3.32. That means the interval for n is equal to 35 is smaller than the interval for n is equal to 60. And you have to explain, why is it so? Well, you see, obviously we expect that since this is here there are only 35 samples, right? The sample size here is just 35. Compared to another case for the same problem, the same scenario, you're having a larger sample, right? Means we're adding how many more? Around 25 more, right? Around 25 more to this particular 35, making it 60. This means that we're going to have a lot more sample size. And because we have a lot more sample size, the expected mean should vary. The interval between the means should all vary compared to 35. And we expect it to actually be, the difference should be wider than or just 35. So we can explain from the angle that the smaller the n, the smaller the interval, the wider the sample size, right? Or the wider the population, the bigger the interval, the wider the interval. So let's see question number 4. So done 1, 2, and 3. We're doing question number 4. Question 4. A random sample of the number of farms in thousands in various states. Something what follows. Doesn't sound right. A random sample of the number of farms in thousands in various states follows. Okay. Estimate the mean number of farms per state with 90% interval. Assume the standard deviation to be 31. So first, remember, let's take our data. This question 4. Okay, I had to increase my pen size. Please, yeah, if you have questions to ask, since it's a live recording, you can type them, and then we see how after the class we can address those questions. 4. Given 90% interval, so the confidence interval is 90%, right? This implies that this is, for 90%, it is 1.65. The Z-score is 1.65. And we've been given, let's go back to the question and check. a standard deviation of 31. So standard deviation 31. But remember that we need the sample size. The sample size n from question 4, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. It also means that the sample size is 31. So this is 31. What are we expected to find? We're expected to find, estimate the mean number of farms. So this is what estimating the mean number of farms. First of all, remember the formula we wrote earlier, where we indicated that to the left we have this minus z-score times the standard deviation over the square root of n plus or minus. So we do the negative, then we do the positive. We subtract and then we add. Okay. Given this, what do we need to be able to find the required? What do we know here? Do we have the mean? No, we've not been given the mean, so we don't know the mean. We have to find the mean first. We don't know the mean. Right. We have to find the mean. What else do we know? Okay, I think we know every other thing here to enable us find mu. So let's find the mean first. The mean is calculated as, let me use brain. Let's see how nice that brain would be. The mean score, there are 31. So obviously we are going to sum up all of this. We'll sum all of this up and divide by 31. You can try that on your own, but I did this unless otherwise. Okay, let's find the mean first. This mean is equal to, remember, we're summing up. The first number is 47, add 95. You add the next 54. You continue adding, right, till we get to the final. I can write all of them here, so that's why I'm using ellipsis. 29. We go back to check. We are actually it's summing up. We're summing up 47 up to 29, and then dividing by 31. Divided by 31. So that this mean, well, I tried and I had approximately, okay, I had 1,347 divided by 31, which is approximately 43.5. It's approximately 43.5, right? So, but I would prefer to use a fraction for the calculation instead of that. But let's be sure of what we've done. A minute. A minute, please. Checking something. Okay. Sorry, let's continue. But if we are to add the whole of this, just have to confirm it later on. Otherwise, we can do it together quickly. It's I have my figures printed out already. The first is 47. So 47. Let's be sure before we proceed. Plus 95 plus 54 plus 33 plus 64 plus 4 plus 90. I've got 90 plus 3 plus 49 plus 4 plus 44 plus 79 plus 80 plus 48 plus 16 plus 68 plus 7 plus 15 plus 21 plus 52 plus 6 plus 78 plus 109 plus 40 plus 50 plus 29 is equal to 1. Okay, so this is correct. 1347 divided by 31. So this is just to confirm our answer to be 43 point, is it 5? 43.5. 43.5. Okay, so I have 43.5. 43.5. Okay, so that's it. Now that we know this value, let's apply it now and see what our results are going to be. So we are applying this formula. So this is the mean is 1347. You can either use that or use a decimal. I want to use this rather. 1347 all over 31 minus, do minus first. The Z score is 1.65, 1.65 times this is 31. The standard deviation is 31, and the N is also 31. This is mean 1347 31 plus, we're doing the right hand side. Remember, it's plus or minus. Plus, we're writing the same 1.65 31 all over square root of 31. You can try this out. I had 34. I have 34 points. 3 less than this, that is, and this other side to be 52.6. Right, that is 4. Any other question? Okay, that's all. There's only one thing. You're supposed to estimate the mean number of farms. Okay, so that's our answer. So the range of the mean is that. So question 5. If Question 5. If the variance of a national accounting examination is 900, how large a sample is needed to estimate the true mean score within 5 points with 99% interval? Okay, how do we solve this problem? Okay, let's begin by having our data first. Okay, question 5. We're given variance, I guess. Yeah, if the variance of a national accounting examination is 900, variance has a square. The variance is 900. How large a sample is needed to estimate? So this time around, how large a sample? We're rather looking for the sample size. So you see, it's a other way around. Instead of finding the mean, we're rather looking for, instead of finding the estimate, we're rather looking for the sample size. And so we can find this using the same formula, but a change of subject would do. So we have N. And what is the 5? Okay, so these are estimates. So estimate 5 points. And what's the confidence interval? Confidence interval. Confidence interval is equal to 99%. And remember, for 99%, what's our Z score? Our Z score is 2.85. I think we wrote that earlier. Let's go back and check. It's somewhere here. No. Here. Okay, 2.58 rather. 2.58. This is 2.58. So that's it. 2.58. So let's substitute. Remember the formula, it's the estimate, which is the same as the mean. This eraser is too large, we'll reduce it. Okay. Better. So this estimate is the same as our mean. So we can write this plus or minus Z score. Right. So I think all we need to do is to make n the subject. How do you make n the subject from here? These are n. We want to make n the subject. Remember, we said this is less than or equal to our mean, right? Less than. Okay, if we had written the negative here, if we had written negative, it would have been this. Right. So we want to make n the subject. So how do you make n the subject? Okay. If we try this, we should get n to be this times that. The Z score times the standard deviation all over expected this in squared. So this all get. Remember that this n here has a root sign. We take this to the other side. It will rather have to take out the root sign. We'll have to square the left hand or the right hand side. So if you want us to try, we can try that quickly and see. I'll call this E, right? So we have that E root n is equal to Z that. So that root n will be equal to Z this all over E. But E has a root, so we'll multiply both, we raise both sides, left and right, by the squares and square that to cancel out. So that's how we have n is equal to this. So let's substitute our values and see what we'll get. This is 2.58 times right. Okay, this is variance, right? But we're supposed to get standard deviation, not variance. So the standard, given variance is squared, and if it's 900, it means that the standard deviation is the square root of 900. Square root of 900 should be 30, right? There's no need to check, but let's just clear it out. Square root of 900 should be 30. That's it. So we have a standard deviation of 30 divided by, what's our E? E is here 5. So what do we get? I have a bracket, a fraction, 2.58 times 30 over 5 squared. So we'll have n to be 239. 239.6. Okay, 239.6. Okay. I just hope we did the right thing. There's no mistake anywhere. Okay, that's 5. Let's move on to question 6. So far, we've spent around 30 something minutes, almost 40 minutes. So let's try question 6. I left 3 more questions to go. Question 6 is, a survey found that out of 200 workers, so it means that n is equal to 200. N is equal to 200. Question 6. N is equal to 200 out of 200 workers. One hundred and 68 said they were interrupted 3 or more times. 3 or more times. They were interrupted 3 or more times. And are by phone messages, faxes, etc. Find the 90% in confidence interval of the population proportion of workers who are interrupted 3 or more times an hour. Okay. So we have n, and what should be our z? I think for 90%, it is equal to the full 90%. So for 90%, what should z be? 90% is 1.65. 1.65. 90% is 1.65. 90%, or is that 90%? So 90% is 1.65. So this is 1.65. But there's a formula. Let's write the formula so we know what direction we're going. This formula, the formula we intend to use is Then plus okay, so let's see what we have and what we don't. So we know what direction to. We have n here, correct? We don't have this p prime, we don't have q prime. Let's find them. Right, we're told that out of 200, how many indicated that they had phone call interruptions? 200, 168 said they were interrupted 3 or more times a day. Right, so what percentage is that? 168. So let's find that percentage. Let's call that percentage P prime. It's 168 all over 200. We divide 168 by 200. Let's multiply by 100. So we get 84%. 84, it's 0. There was even no need multiplying by 100. So that we just have 168 all over 200 because we need this value, not this one. 0.84. If it is 0.84, that means Q prime would be 1 minus, what do we need? This is 84%. How many more percent do we need to get 100%? So it's going to be 1 minus 0.84. And that should be 16%. 16% is 0.16. So we now know, we know N, we know P prime, we know Q prime. We also know this to be 1.65. We know this. So that means, voila, we're good to go. So let's substitute now. Not much. Let's substitute. What is this? This is 0.84. So 0.84 minus, this is 1.65 times the square root of, what is P? P prime is 0.84 times Q prime is 0.16 divided by N. What is our N? It's 200. This should be less than, this should be, we'll repeat the same thing, 0.84, so minus, we make it plus 1.65. The square root of 0.84 times 0.16 divided by 200. Okay, so what do we have for doing this? What do we have for doing this side? Okay, this should give us, let's try it together. .84 minus 1.65 times the square root of 0.84 times 0.16 all over 200. Okay, this is 0.79, 0.797. 0.797. It's less than. We do the same for the right hand side. All we need to do is to change the value, the sign, sorry. We only have to change the sign from negative to positive. That's it. So 883. 883. So take note that this means that P is between 79.7%, and 83. We can see that with 90% confidence, the true percentage is between 79.7%, 79.7% and 88.3%. So that's it. Question 6. Let's try 7. What is question 7? The average 1-year-old, both genders, that is male and female, is 29 inches tall. A random sample of 31-year-olds in a large daycare franchise resulted in the following heights. These are the heights, and we've been told that there are how many already? How many? 30. So the sample is 30. Now we'll count all of this, you get 30. So what have we been given? We have been given standard deviation and this. And what else? Okay, so let's see what we can do. Unfortunately, I don't have my table here to make reference to, but I'll just explain the answer. And maybe probably later on, when we have time to answer questions, we can show details of how we got some of these figures from our tables. I don't have the table at the moment, so for question number 7, what are we actually asked to find? The question is, at this 0.1, okay, can it be concluded that the average height differs from 29 inches? So there's either a yes or no. It is either yes, it differs, the average height differs from 29 inches, or no, the average height does not differ from 29 inches. So this is going to be question based on hypothesis. So let this be such that average height doesn't differ. And the other hypothesis is that, oh, it differs, so it's not 29. It differs. And that is a claim in the statement. The question we just read, that is a claim. So with this, you can see that it's a two-tailed test, where we're given n to be 30. From our table, we should get this to be 2.61. And our mean, I think we should have written the mean first. Is 29.45. S is this 0.05. Remember, we're given this to be in the question, it was 0.1, but we rather need, remember, all the while we've been writing this over 2, so we need lambda over 2, which is 0.1 divided by 2, and that is 0.05. So that's why we're using this to 0.05. Right. So is equal to plus or minus 1.96. So what's our test value? Our test value is equal to this minus that divided by S all over square root of n. Let's quickly do this. Substitute the values. Here is 29.45 minus, what does that mean? 29 S is 2.61 divided by the square root of, what does that mean? Okay, our sample is 30. You can try this. You should get 0.944 if properly done. Okay, so what does this mean? This is about 94.4%. This means that we should not reject the null hypothesis. Do not reject the null. Do not reject the null hypothesis. Okay. The next question is 8. I think I have 2 more questions to go. A score manager hypothesized, wow, it's a big word, hypothesizes that the average number of pages a person copies on the store's copy machine is less than 40. A sample of 50 customers orders is selected. At this is equal to 0.01. Right. So is there enough evidence to support the claim? Let's use the p-value hypothesis test method. Okay, a minute. One minute. Okay, question number 8. Okay, let's solve this together. I just check in. I just realized that we're asked to use a p-value. Use a p-value hypothesis test method. Okay, so I think we can also use a z-value. Let's use a z-value for this particular presentation, and later I'll add on the p-value. question 8. Okay, we're using the Z value. So N is 50 from the question. You can go back and read. We're told a sample of 50 customers. So N is 50. $30.9. This mean is 40. X is, well, if X is the number of pages a person copies on the store's copy machine, it means that the mean here is summation X over N, which is equal to 1463 over 50, and that would be 29.26. So null or alternative hypothesis. For the null or alternative hypothesis, we have that let's just repeat this. We have, I think I probably shouldn't have written this, so there's no need. I just mentioned this, but take note there are two, yes or no. I'm writing that at the top here. So this is not detailed, right? Sample size is greater than 30. So Z test is appropriate test null hypothesis. So let's do the Z test. Oliver. So this is equal to 29.26 minus 40 divided by 30.9 all over square root of 50. If properly done, this should be negative 2.46. So what's the critical value? You see the value, the level of significance is 0.01, right? And so we found this to be that. If the critical value, we're going to compare this value to the critical value and see which is higher and which is less, whether to accept or reject. For the critical value, Z is equal to 0.01. It is given as 2.326. We're not calculating this value, we're picking this value. So the statistical decision is that since, which is greater, let's compare. I think this is greater than the other. So since the Z test is less than a critical value, or since the critical value is greater, we can see that this 2.326 is actually greater than 2.46. What does that mean? So reject the null hypothesis. So reject the null hypothesis. Right. So what this simply means, remember that we were told that the store manager this word, if I not bite my tongue, hypothesizes that the average number of pages a person copies on the store's copy machine is less than 40. It's less than 40. So based on a calculation, it can be concluded that the average number of pages a person copies on the store's copy machine is actually less than 40. That's why we're asked to reject the null hypothesis. Okay. Last but not least, we're doing we're doing question 9, which is the last question. I'm sure, considering the time, some of us are heaving a sigh of relief. Researchers, where's that question? Okay, researchers suspect that 18% of all high school students smoke at least 1 pack of cigarette a day. Wow, at least 1 pack. At Wilson High School, with an enrollment of 300 students, a study found that 50 students smoked at least 1 pack of cigarette a day. At 0.04, test the claim that 18% of all high school students smoke at least 1 pack of cigarette a day. So we're going to test the claim and either accept or refute it based on the calculations we're going to do. So let's proceed. First, we're told that for the first hypothesis, P is greater or equal to 0.18, 18%. The second should obviously be the opposite. But not exactly, because this is greater than or equal to, but this is rather greater, less than 0.18. You can see that this corresponds to, because this value is, this is greater than or equal to, but the other is less than. So because it's less than this can go far beyond 0.18 to the left, because it's less than. So you see that most of our values are tailored towards the left hand, for which a z-test for one population should be used. So based on the information provided, the significance level is this is 0.05. Remember, 0.1 divided by 2. And the critical value for a left tail test, what's the critical value? This already is constant. We're just supposed to pick this value, 6449. Keep this value in mind. Then to reject the region for this left tail test is, so we know the region that we are considering. This region is bounded by Z such that Z is less than negative 1.6449. So let's apply this formula. The formula is Z. We're going to compare to that. Z is equal to prime not square root. Well, this space is too small. Permit me to rewrite this somewhere else. I'll probably reduce my font size. I can write here. Z is equal to, there's a square root at the bottom here. At the bottom of the square root, we have P naught, 1 minus all over n. But here we have P minus P naught. So let's substitute these values there into what we get. How do we get this value? Remember, this is 50 out of 300 minus this value is here, 0.18 divided by square root of 0.18 times 1 minus 0.18 divided by 300. If properly done, this should give us approximately negative 0.60113. But you see that this new value here, which is Z, is greater than, this Z is greater than the critical value. What was our critical value? This critical value was here. But this Z is rather here, which is greater. So remember I mentioned that we're going to compare. Comparing this to that, you see that this is greater than the other. And since the Z is greater than Z critical, it simply means that the null hypothesis should not be rejected. The null hypothesis should not be rejected. Since you can write that since this is greater than the null hypothesis should not be rejected. Okay, thank you for your time. At least there wasn't so much disruption in this video. Please comment and share. Comment and share with your colleagues. And what you think about this particular presentation. Right. You can come back for those of you that are going to present this as an assignment. You can come back and watch the video later and rewrite properly. So see you Wednesday when we meet, hopefully. Good night. I'm ending my Zoom meeting.